Chapter 9, page number 308, the iris, anatomy of the iris. Gross appearance. The iris is the most anterior portion of the uveal tract. It lies in the frontal plane of the eye, between the anterior and posterior chamber, and is bathed on both the surfaces by the aqueous. It is continuous peripherally with the anterior aspect of the midpoint of the ciliary body, and in this way, an anterior band of the ciliary body and the scleral pore into which it is inserted contribute to the boundaries of the anterior chamber at the drainage angle. The diameter of the iris is approximately 12 mm and its circumference 38 mm. It is thickest, that is 0.6 mm at the collarette, and thinnest at the iris root, that is 0.5 mm, where it is readily torn away from its attachment to the ciliary body by contusion, injury, or as a surgical procedure, iridodialysis. The pupil pierces the iris diaphragm slightly below and nasal to its center, but lying on the optical axis behind the optical zone of the cornea. The pupillary margin rests lightly on the anterior surface of the lens so that it lies in a plane anterior to the iris root. When the lens is removed in aphakic conditions, the iris is flat, that is, its root and its pupillary margin of the iris, they come to lie in the same plane when the lens is absent, because when the lens is present, the iris root is bent backward to form the angle faces that we have seen in the anterior chamber angle anatomy. Contact between the posterior surface of the iris and the lens creates a relative pupil block to the flow of aqueous humor to the pupil, which is most marked in mid-dilatation. This may encourage a forward bowing of the iris. Physiological Bombay, which in predisposed narrow angles may precipitate angle closure glaucoma. Embryologically, the iris can be divided into 3 layers, 2 anterior layers and a posterior layer. Originally, the anterior layers were termed mesodermal, but in view of the major contribution of neural crest cells to their development, they are more appropriately designated as mesenchymal. Superficial mesenchymal layer. The superficial mesenchymal layer is shorter than the deeper layer and extends from the ciliary border to the collarette, which forms a dentate fringe separated to a varying degree from the middle layer. This superficial layer gives the ciliary portion of the iris its structure. In it are the iris crypts, bounded by the tuberculi of the collarette, which are the remains of obliterated vessels that passed to the pupillary membrane during embryonic life. So this point needs to be noted. Deep mesenchymal layer. The deep mesenchymal layer extends from the ciliary border to the pupillary edge. In lightly pigmented irides, it has a radial fibrillary appearance and is transparent, so that the deeply pigmented ectodermal layer is visible through it. The superficial mesenchymal layer is only loosely attached to the deeper one and glides freely over it. It does not participate greatly in movements of the rest of the iris. Thus, as the pupil dilates, the pupillary edge approaches nearer to the collarette, so that the pupillary remnants, when present, may seem to rise from the pupillary margin and not the collarette itself. So they're talking about the persistent Pupillary membrane. Usually what happens, the pupillary membrane is derived from the second wave of the neural crest cells, which are the differentiated cells from the neuroectoderm of the anterior-most portion of the optic curve, from the rim of the optic curve. From there they migrate in between the cornea and developing lens, and there they form the primary pupillary membrane, and which contributes to the formation of the iris stroma. Its development begins, it starts forming at around 6th week of gestational age, when the fusion of the embryonic fissure starts. From 24th weeks of gestational age, that is around 6th months of gestational age, what happens? The vessels at the center of this primary pupillary membrane and also tunica vasculosa lentis, they start getting obliterated. The blood flow through these vessels, it ceases, and then due to activity of the macrophages, they disappear. The primary pupillary membrane, it is resolved completely at around 9 months of gestational age, that is at the starting of 9th month of gestational age. It happens before the birth. When it is present after the birth in fully newborn babies, it usually disappears in around a year of life, but when it fails to do so, and when even before that it is present in the visual axis, that's blocking the visual stimulation of the retina, because central 1.5 millimeter area of the pupil is very important for the normal development of the brain visual cortex, and it's because of the stimulation of the retina because of the light. So this area is very important, and when there is a deep persistent pupillary membrane stuck over there, it needs to be removed either by the laser or surgery. And the laser used for that is Q-switch Nd:YAG laser, which works on the principle of photodisruption. Photodisruption means it is the ionizing effect of laser. Now laser, it works by three main mechanisms: thermal effect, then there is chemical effect and ionizing effect. The thermal effect can be categorized into two types: photocoagulation and photovaporization. Photocoagulation, the temperature rises from 37 degree to 50 degrees centigrade, causing the tissue damage due to the denaturation of the proteins at this high temperature. And photovaporization means obviously there is a boiling point of the water. The tissue gets heated to the boiling point of the water, that is 100 degrees centigrade, and it causes the denaturation of the proteins and the tissue damage. Then the second effect is chemical effect. Again, it is further categorized into two types. There is photoablation and photoradiation. How the photoreception works: in a laser cavity, inert gases like krypton or fluoride are used. Now krypton and fluoride, they combine when the electrons are bombarded towards them. They get excited and they form the metastable compound krypton fluoride, and it is not very stable compound. When it comes back to its normal krypton and fluoride molecules, it gives out the laser energy, and that is coherent. Another example of photochemical effect is photoradiation. In photoradiation, what laser energy does is it causes generation of the free radicals like singlet oxygen, triplet oxygen, and it causes the tissue damage to these free radicals. Then there is photodisruption, Q switched Nd:YAG. The temperature rise in photodisruption is from 100 degrees centigrade to 15,000 degrees centigrade. At this high temperature, what happens? The electrons from the atoms are stripped off, and then it creates the full state of the matter, that is plasma, and bubble formation and hydrodynamic and acoustic wave that traverses through the tissue and it cuts the tissue. So that is the photodisruption, and this is summarized in this following chart. The persistent primary pupillary membrane can be broken, can be treated with Q-switched Nd:YAG, which works on the basis of photodisruption. Now, coming back to iris, the persistent primary pupillary membrane, it is divided into three types. When the persistent primary pupillary membrane is attached to the iris, it is type 1. When it is attached to the lens, iridolenticular, it is type 2. And type 3, it is attached to the cornea, like seen in Axenfeld-Rieger syndrome. It's one of the differential diagnosis of persistent primary pupillary membrane. Then coming back to deep mesenchymal layer of iris, there are other changes as the pupil dilates. The pupillary ruff becomes thinned and may disappear. There is a more distinct step between collarette and pupil margin. The crypts become oblique. The vessels more tortuous, and the contraction and peripheral furrows deepen. The border zone disappears. The pupil regulates the entry of light into the eye. It is a pinpoint in bright sunlight and widely dilated in the dark. The range of pupil diameter lies between 1.5 and 8 mm in youth. In old age, the resting pupil size is often smaller because of fibrotic changes in the sphincter and atrophy of the dilator muscle. The pupil can be dilated to over 9 mm with Midriatic drops, but dilatation is restricted in diabetics by dysautonomic changes. So, in this paragraph, one thing is very important. In older age, the pupil size is smaller than as compared to the younger age. Why it is so? Because there is atrophy of the dilator pupillae muscles. They don't work normally means they don't work as effectively as in youth. And the sphincter pupillae muscles, they become fibrotic. So they constrict and they cause pupillary constriction. And the Midriatics, they dilate the pupil and it can be dilated over 9 mm. Usually it can be dilated in the dark room. Normally under physiological conditions, the pupil dilates up to 8 mm, but with Midriatics, it dilates to over 9 mm. And this dilatation with Midriatics is restricted in diabetics by dysautonomic changes. The sphincter encircles the pupil, is innervated mainly by parasympathetic nerve endings and constricts the pupil on contraction, that is meiosis. The dilator muscle fibers run radially. Innervation is chiefly by the sympathetic, and contraction of these muscles dilate the pupil, midriasis. These muscles show a reciprocal innervation. Pupil constriction occurs during accommodation for near and improves the depth of field while reducing spherical aberration. It also occurs during inflammation or after injury in response to fifth nerve stimulation and release of mediator substances such as prostaglandin or substance B. Color. Iris color is determined chiefly by the melanocytes in the stroma and anterior border layer. Anterior border layer and the stroma, they determine the iris color mainly. The iris color is chiefly determined by the anterior limiting layer and the stroma, the melanocyte number in these two layers. When the iris is brown, the melanocytes are profuse and well pigmented. In the blue iris, there is paucity of melanocytes, and while the longer wavelengths of light are absorbed, the shorter wavelengths in the blue region of the spectrum are backscattered or reflected. The stroma of the blue iris contains amelanotic cells whose non-pigmented granules are of unknown composition. The albino iris is pale, buff-colored because of the absence of pigmented melanocytes. Now this buff color, it ranges from pale yellow to pale brown, and it is shown below the buff color range. The buff color palette is shown below in the picture, how it looks. With increasing levels of illumination, the iris takes on a pinkish color because light which has traversed the sclera and pupil With increasing levels of illumination, the iris takes on pinkish color because light which has traversed the sclera and pupil transilluminates the iris from behind. Now what is transillumination? Now on a slit lamp there is transillumination technique. Transillumination technique, for that we reduce the beam of the light and it is around 1 millimeter by 1 millimeter, and we focus the central part of the pupil and the light falls on the retina. In normal iris, what happens? The iris is heavily pigmented, brown iris, and the light reflected from retina, it doesn't pass through the iris and we cannot see the light passing through the iris. But what happens when there is albinism in case of pigment dispersion syndrome and in pseudo-exfoliation syndrome? There are transillumination defects. Means what happens? The light that is passing through the pupil and falling on the retina, it is reflected back, and through the pigmentary defects, the light traverses through the iris to these pigmented defects and it reaches the examiner's eye, so we can see that part, that defective part is illuminated. So this technique is for that, and this is also used to see the patency and location of the iridectomy. And this transillumination technique, how it is done, I have shared some videos. I have added some videos in this video. So I hope you understand, and I hope you learn how the transillumination is done and what is its significance. The transillumination defect is at the mid-periphery in albinism and in pigment dispersion syndrome, and it is near the pupillary margin in pseudo-exfoliation syndrome. So transillumination defect has a very significance, clinical significance. So you should know the transillumination technique and its significance. For that I have shared the videos here in this video only. So I hope you will understand what transillumination is. Iris color is inherited, brown as a dominant trait, blue as a recessive trait. In Caucasians, the iris is blue at birth because of paucity of stromal melanocytes. By the age of 3 to 5 months, it adopts its adult coloration. In the black and brown races, there is a denser stroma and some pigmented melanocytes, so that at birth, the iris appears a slate green. In some individuals, there is a segmental variation of iris color, or the color may be different between the two eyes, heterochromia. Before I make a video on microscopic appearance of iris and microscopic structure of the iris, that is different iris layers, before talking about that, I would like to cover the heterochromia of iris. Okay, so there is heterochromia iridis and heterochromia iridum, these terminologies, and the plural of iris is irises. So heterochromia iridis and heterochromia iridum, what are these and what are the different types of the heterochromia, what are the causes of the heterochromia? That I'll be talking about the other video, and after that video I'll be talking about the microscopic appearance of the iris and different layers of the iris, that will be covered in microscopic appearance of the iris. Thank you.
I am Dr. Sharjeel, and today I would like to show you slit lamp transillumination technique, transillumination of the iris. So for that you have to minimize the horizontal as well as vertical length of the light beam, like here we are doing. When you focus the beam of light as such that all light passes through pupil, it then touches the retina and reflects back and highlights any atrophy, any hole, any cyst, tumor in the iris or ciliary body, pigment dispersion syndrome, pseudo exfoliation syndrome, Transillumination occurs near the pupil in pseudoexfoliation, whereas transillumination occurs at periphery of the iris in pigment dispersion syndrome. It also helps to identify ciliary body tumors that is normally hidden behind the iris. Now here in angle closure glaucoma case, PI has been done, and you can see while passing the small slit of light into the pupil at 12 o'clock, the peripheral iridotomy or iridectomy has been illuminated. So it not only tell you whether it is patent or not, but also its exact location. And this transillumination technique also tells you about the intraocular foreign body path in the iris as well. So transillumination technique can tell you about number of ocular conditions, and it is very easy to master. You just have to pass the light, all the light into the pupil, and it will highlight. Now here ocular albinism is also highlighted here. So it's an easy technique and it's a must technique to know. So that's all about transillumination of the iris. Thank you very much.